Okay, now just to review, with solving system of equations, we got y by itself. So we had y equals negative 3x minus 9. And then this next one, we would get y by itself as well to solve by graphing. So we would add the 3x and then divide by negative 2. So we would have y equals negative 3 halves x minus 6. And we would graph those two lines, and their intersection point would be our solution. Well, I'm going to teach you two different ways now you can solve a system of equations. You don't necessarily have to do it by graphing. You can do it by graphing, by substitution, or by elimination. So we've already discussed graphing. So today I'm going to focus on substitution and elimination. And this is maybe for those of you that, one, don't want to take the time to graph, and two, just don't like graphing all that much. So first we will discuss substitution. All right, so what this is you are essentially solving one equation for a variable, either variable of your choice, and then you are taking that variable and substituting it in for that same variable in the other equation. So in this case, I looked at my two equations and I said, all right, I have a y by itself. It's going to be really easy to solve this equation for this variable. And that's what I did. I subtracted a 3x from both sides right here, and I got y equals negative 3x minus 9. I then took what y equals, which is negative 3x minus 9, and I substituted that in for y in the other equation. So that's where this negative 3x minus 2 and then parentheses negative 3x minus 9, because I took away this y and I plugged that negative 3x minus 9 in for it, because that's what we said y equals. So I plug that in there, have it equal to 12, and then this is all me just simplifying that. So I distributed the negative 2 to both of the terms behind it, which got me the plus 6x and the plus 18, plus 6x and the plus 18. And then I combined my like terms, and I got 3x plus 18 equals 12. Subtracted 18, got 3x equals negative 6 divided by divided by 3, and got x equals negative 2. So that's what x equals. Now, if you remember, we have two variables. We need to know the x and the y. We need to know both of them to see that intersection point. Or in this case, there's two unknown variables, x and y, and we need to know both of them. So now, once we have what x equals, we can take that and plug it back into either x in this equation or in x here or here. It doesn't matter where, just plug it in for x in one of the three equations that you have and solve for y. I chose to plug it into this original one up here. So that's why I have 3 times negative 2 plus y equals negative 9. So that's negative 6 plus y equals negative 9. Add 6 to both sides, we get y equals negative 3. So your solution, I don't know why I didn't write it, is actually still written as an ordered pair. It's negative 2, negative 3. Now, really, this equation is easy to do using substitution. It's also easy to do using elimination, and I'll explain why. Elimination is actually my personal favorite way of solving systems of equations. Okay, what elimination is you essentially add the two equations together, and in doing so, one of your variables will eliminate. If you look here, the reason I say this one is easy, because if you look, my x variables are already opposites of each other. I have a positive 3x and a negative 3x. So when I add those, they will cancel out. So if we add that, 3x plus negative 3x is gone. It's 0x. It cancels out. 1 plus negative 2y is negative 1y. And negative 9 plus 12 is 3. So that's where this negative 1y equals 3 comes from. It's just me adding these two equations here, and that's the result. So we solve for y, and we get y equals negative 3. Again, once we have one variable, what that equals, we can just take that and plug it into any of the other equations and solve for the other unknown variable. So I took that y equals negative 3 and plugged it into my first equation there. So I have 3x plus negative 3 equals negative 9, or 3x minus 3 equals negative 9. So I added 3 to both sides and got 3x equals negative 9. Or sorry, 3x equals negative 6. And then I divide by 3, we get x equals negative 2. And again, I did not write my answer as an ordered pair, so I will. Negative 2, negative 3 would be my solution. And we can always check that and make sure it works. Clearly it probably does, or clearly it does, because I got it for both substitution and elimination. But just to be on the safe side, 3 times negative 2 is negative 6. Negative 6 plus negative 3 is negative 9. It works there. Now remember, to be a system of equations, x and y have to equal the same thing for both equations. So I'm not only going to just check it for the first equation, I'm going to check it for the second as well. So negative 3 times negative 2 is positive 6. Minus 2 times negative 3 is positive 6. 6 plus 6 is 12. So that checks out, which is great for us. All right, now let me show you an example where it's not as clear-cut or straightforward, like in this case. Notice there's no variable that's by itself, like there's no variable that has a coefficient of 1, I should say. So when we solve for a specific variable, again, it's just your choice. I looked at this first equation and I noticed that everything was divisible by 2 and that m had a coefficient of 2, so I decided to let's solve this equation, this first equation, for m. Because that way I'm not dealing with decimals or fractions. So in doing so, for substitution, I got this. M equals negative 2n minus 2, because I subtracted the 4n and then divided everything by 2. Then I took what m equals, which was this negative 2n minus 2, and I substituted it in for m in the second equation. So that's why I have 3 times negative 2n minus 2. And then we distributed the 3, so got negative 6n minus 6 plus 5n equals negative 3. Combined my like terms, negative 6n plus 5n is negative 1n minus 6 equals negative 3. Now I'm going to add 6 to both sides, so I got negative 1n equals 3, divide by negative 1, n equals negative 3. And again, once you have what n equals, you can plug it into any one of your equations. I could plug it into this equation here or any one of my 2 original equations. I chose to plug it in for this m equals negative 2n minus 2. So I have negative 2 times negative 3 minus 2. Negative 2 times negative 3 is positive 6, and 6 minus 2 is 4. So typically when you write ordered pairs, you do it in alphabetical order. So since these variables are m and n, it's going to be m first and n second. So my ordered pair is 4, negative 3. Let's look at how we would do an elimination this way. Like I said, elimination, you add the 2 equations, but as you can see, none of them are opposites of each other. Actually, they're all positive values here. So I have to manipulate the equations and make it so I can solve them by elimination. So I chose to cancel out my m's, just because they're smaller numbers than 4 and 5. And I'm going to do that by making both my coefficients a negative, or one is positive 6 and one a negative 6. So to do that, I multiplied my first equation by 3. And what you do to one thing, you have to do to everything. So multiply by 3, we get 6m plus 12n equals negative 12. And then I chose to multiply the second equation by negative 2 to make that those m's opposites of each other. So that gave me negative 6m minus 10n equals 6. And when I added those, then the m's canceled. 12 plus negative 10 is 2, and negative 12 plus 6 is negative 6. So I was left with 2n equals negative 6. Then I solved for n, got n equals negative 3. Again, I have n, so I take what n equals and plug it into any one of my original equations here, or either one of these, and solve for the unknown, solve for m. I'm going to plug it in, where did I plug it in? To the first one, first equation here. So I had 2m, and then 4 times negative 3 is negative 12, so 2m minus 12 equals negative 4. So I then added 12 both sides and got 8. Divided by 2, we get 4. So my ordered pair, again, written as mn, is 4, -3. Okay, I want you to go ahead and try this problem. Try solving it both ways, by substitution and elimination. And I will put the solution up here. And if you can't figure out how I got the solution by either method, bring that in and we'll discuss that tomorrow with any other questions you might have. Okay, here's what I got. I got -12 equals 25 and 0 equals 35, which this was by substitution. And because those values do not equal each other, this would be an inconsistent system, meaning it has no solution. So there isn't an ordered pair where they intersect. It is where they're probably parallel lines when we graph them. And this 0 equals 37, again, that doesn't equal, so that 2 is a no solution. Because when I tried to solve by elimination, I multiplied the first equation by 2, and the x's and the y's all canceled out. So that left me with 0 equals 37. Go ahead and try the checkpoint quiz. I promise you'll have an intersection there.